Hello, welcome to the Mathtuber. My name's Mrs. Glenn, and we're going to go over some of the exponential properties. So here are the first four, and if you take a look at the bottom here, there's four choices to pick from. So what I want you to do is I want you to take a look at these four and kind of guess what you think the answer will be depending on the one that I'm talking about. So let's take a look at the zero exponent property first. So go ahead and pause this video and guess if you think it's A, B, C, or D. And now let's take a look to see if you were correct. So out of the four choices, it would be B, and that's because it has a zero exponent, hence the name. So that what that means is anytime you raise a letter or number other than zero to the power of zero, it actually equals 1. And the reason for that is raising a number or letter to the power of zero is the same thing as dividing it by itself. So when you divide a number by itself, it equals 1. And then let's take a look at a real world example. And that would be 4 to the power of 0 would equal 1. Okay, now go ahead and pause this one and take a guess for negative exponent property. I'll give you a hint, it's not B. All right, so let's take a look and see if you got this one correct. It would be A, hence that it has a negative exponent. Oh my goodness, do you see a pattern? All right, so x to the power of -1, that means that what you do is you take this entire exponent, get rid of the negative, and put it under 1. Okay, so get rid of the negative and put the entire exponent under 1. Now, if this was actually a number raised to a number, you could actually calculate this denominator. But because these are both variables, you just keep it like this on the bottom. But once you put it under 1 as a fraction, you take away the negative sign. Now, if this negative was on the bottom, you would actually move it to the top. So just what it does is it changes the placement of the exponent. So if it was a numerator, like this actually is a numerator to start because it has 1 underneath it, it just takes the reciprocal of that and puts it down here. Now if this was -1 down here, you would move it up to the top and 1 would be on the bottom. So depending on the placement of the negative exponent, it just flips to the opposite side of the fraction line. All right, and of course it can't work with 0. So let's take a look at what that looks like as a real world example. So you have x to the power of -2 equals 1 over x squared. So you just get rid of the negative and put everything under 1. All right, let's take a look at product of powers property. Go ahead and pause the video, pick between C and D. All right, let's take a look and see if you're correct. And it was D, so product means multiply. You probably learned that back at elementary school. X to the power of n times x to the power of m. See how these two x's match? They have the same base. Then all you do is you add the two exponents together. So x to the power of n plus m, and of course it doesn't work with 0 again. So if they have the same base, you add the exponents. So let's take a look at and see what an example would look like. We get 2 to the power of 3 times 2 to the power of 5. So we just add the 3 and the 5 together and get 8. So 2 to the power of 8. Now obviously you can calculate 2 to the 8th power and go even further, but we're just showing you how to add the exponents in this example. And of course the last example would be C. And quotient means divide. So when you have two exponents that are dividing and they have the same base, you subtract down. So it's going to be n minus m. So x to the power of n minus m. And that only works if these two bases are the same. So these x's have to match. And they could be any letter or any number. They just have to be the same. And of course, it doesn't work with 0 again. So let's take a look and see what the example would look like. So you have x to the power of 5 divided by x to the power of 2, or x squared. So you just subtract down 5 minus 2, and you get x to the 3rd power. And let's take a look at the last four exponential properties. You got power of a product property. So power of a product, remember that's multiplying. So go ahead and pause the video and pick between A, B, C, or D. And let's see if you're correct. And it is D. So power of a product. So two things are multiplying and there's a power on it. So hence the name power of a product. So these two, what you do is you have to distribute this n, or the exponent, into everything inside the parentheses. So it's the same thing as if you had a number out here for the distribution method. you would distribute that number into everything in the parentheses. Same thing as the exponent, you do the same thing. So it's x to the power of n times y to the power of n. And this problem actually can go backwards or forwards. They could give it to you like this and want you to change it into this, or they could give it to you like this and want you to change it into this. And a lot of time they want you to go this direction, and the reason why is because these won't necessarily be letters, they'll probably be numbers. And when you do that, you can actually calculate it. And let me show you an example of what I mean by that. So you have 3 to the power of 3x squared, or 3x raised to the power of 2. So when you distribute that 2 into the 3, you can actually calculate 3 squared, and that would equal 9. And then x squared just stays the same. So 9x squared would be your answer for this one. So that's why they want you to actually break it apart like this so that you can calculate that 3 squared. All right, go ahead and pick for power of a quotient property. Remember, this one was multiplying, so quotient means dividing. Go ahead and pause the video and pick between A, B, or C. All right, let's see if you're correct. So it's x divided by y raised to the n power, hence the word quotient means dividing. So you distribute the n into each of the numerator and the denominator, so it's x to the nth power divided by y to the nth power. And then that would look like this. So 2/3 raised to the second power, distribute the 2 into each of the numerator and denominator, and you get 2 squared divided by 3 squared, so then your answer would be 4/9. And then we have power of a power property. Go ahead and pause and pick between C or A. Okay, let's see if you're correct. You have x to the a power raised to a b power. So it's power, hence x to the a has to be a power in the inside, raised to another power. So there's another power out here. So because these two are being raised, or this x is being raised twice, you have to multiply it. Now, a lot of people get this confused with the product of a powers property, where you add the two exponents, but do you see how these are separate? So you're not going to multiply them because they're already being multiplied. So in this situation, because they're being raised to two exponents, we have to multiply the two exponents together. Just like if you were to distribute that b into here, you would multiply it with it. Hence the reason why we put this in here, we're raising it to that power. All right, let's look at an example. We've got 3 to the 1/2 power raised to the 1/4 power. So we multiply the two fractions together, and you get 1 times 1 equals 1, and 2 times 4 equals 8. So your answer would be 3 to the 1/8 power. And this example actually leads into our last one about rational exponent property. And this is when you're dealing with radicals. So radicals are this little square root symbol that a lot of times you just call a square root, but it's actually called a radical. The number underneath is called a radicand, just so you know. All right, so when you have a fraction exponent property, or fraction exponent, what you do is you take the denominator, and that goes up to the front as the root, and your numerator stays as the exponent. So this 1 is actually still here, but it's the exponent that's on this x right there. So you just leave that exponent here underneath the radical, and if you can calculate it, like if this was actually a number and this was something more than 1, then you would calculate it. So the denominator becomes the root, or the front number, and your numerator stays on as the exponent. And you need to know to be able to go backwards and forwards between this, because sometimes they'll give it to you like this, and they'll ask you to calculate it, using the quotient of powers property, where you had this, where you would then have to go and subtract the two fractions. So you need to be able to know to go from this back to this, and then from this to this. So you should be able to go backwards and forwards with this kind of problem. And let me look at an example. So you have 3 to the 2/3 power. So you take your denominator, put it as the root, that's the front number, and the top number becomes the new exponent. So 3 squared you can actually calculate, and that turns into a 9. So this is the cubic root of 9, or the third root of 9. A lot of people just say the cubic root of 9, or cube root of 9, either way. So that's how you do the 4 exponential properties, and I hope this helps you understand how to calculate exponents, to be able to graph them, and use them in algebraic expressions. Have a great day.